Welcome back to the Deep Dive. We're here to take that stack of articles and research you send us and, well, turn it into strategic knowledge, a shortcut to understanding what's next. And if you're the learner, someone optimizing for insight and efficiency, this is absolutely tailored for you. Today, we're really moving past the early hype around generative coding. For the last couple of years, AI has been great for, scaffolding, boilerplate, maybe a quick fix, like an incredibly fast, but sometimes pretty careless junior programmer. But the sources we've been looking at tell a completely different story. It seems AI is moving beyond just coding. It's becoming a true, full-stack, process-driven engineer.
And that shift is exactly what this Superpowers framework is all about. It's not just another model. It's a whole skills library designed to impose rigor. So you take a basic coding agent like a Claude Code or a Codex, and Superpowers acts as this external enforcement layer. It moves them from suggestion to mandate.
Okay, let's unpack this. Our mission today is to trace the entire life cycle of AI development under this system. We need to see how it takes a basic AI and forces it to adopt things like test-driven development and systematic planning. We're really looking for the blueprint here.
To start, you have to get the philosophy. Superpowers isn't just a tool. It wraps the entire development workflow. It establishes initial instructions that are, well, they're mandatory, not suggestions. The AI agent literally cannot proceed until it satisfies these process steps.
And that philosophy, it feels like a critique of human development habits, doesn't it?
Yeah.
It seems designed to counteract the tendency of these big models, and let's be honest, a lot of human developers, to just rush and cut corners. So what are the core principles, the underpinnings that govern everything the agent does?
There are 4 pillars, and they're non-negotiable. First, and this is the big one, is test-driven development, TDD. Tests must be written first. Always.
Always, okay.
Second, systematic over ad hoc. The agent has to follow a process, not just guess or improvise. Third is complexity reduction. Simplicity is the main goal. If it can be simpler, it has to be simpler. And finally, evidence over claims. You never, ever declare success until you've run the verification and it's passed. If an agent tries to skip any of this, the framework just blocks it.
That systematic approach, starting before any code is even written, is just brilliant. It avoids that classic problem where the developer or the AI misunderstands a vague request and then builds the wrong thing perfectly.
Right.
So what happens when a human gives the agent a high-level task?
It immediately activates the brainstorming skill, and this is a deliberate stall. It does not write code. Instead, it starts this Socratic design refinement. It basically forces the human user to move from a vague idea to a concrete specification by asking all these clarifying questions, exploring constraints, teasing out the edge cases.
Wait a second, isn't that just pushing the cognitive load back onto the human? I mean, if I wanted to write a detailed spec, I probably would have done that in the first place.
Well, yes and no. The AI is much better at refining a half-baked idea than it is at inventing a solid structure from scratch. So the human might say, build me a data parser.
Mm-hmm.
And the agent will come back with, okay, what are the input formats? What failure modes do we need to handle? What's the required output schema? It uses brainstorming to generate a structured spec so everyone's aligned before work starts.
I see. So it turns a quick conversation into a reliable, agreed-upon design document. The sources also mention that it presents this refined design back to the human in, and I'm quoting, chunks short enough to actually read and digest.
Yeah.
It's like the AI is enforcing project management discipline on the human.
Precisely. And that sign-off is what transitions you into the planning phase.
Okay, once that design is approved, this is where it gets really interesting. The agent has to create a detailed implementation plan using the writing plan skill. What are the standards for that plan?
The standard is, honestly, one of the most brilliant things we found in the sources. The plan must be clear enough for, and this is a direct quote, an enthusiastic junior engineer with poor taste, no judgment, no project context, and an aversion to testing to follow.
That's saying the plan needs to be absolutely foolproof. It has to have every single detail, leaving zero room for interpretation.
Exactly. The plan is a step-by-step manifesto. It has to break all the work down into these tiny, bite-sized tasks. We're talking 2 to 5 minutes of work each.
2 to 5 minutes.
And that granularity is key. It limits the scope of any potential failure and makes automated review so much faster. It stops the agent from getting lost.
And every single one of those tasks has to specify the exact file paths, the complete code, not just a description of the code, and the explicit verification steps.
Yes. And embedded in that plan are those strict disciplines we talked about. True, red-green TDD, YAGNI, you aren't going to need it, and DRY, don't repeat yourself.
Right. So that moves us into the implementation phase, which is all governed by the test-driven development skill. Walk us through that mandatory cycle.
It's an unwavering red-green refactor cycle. First, the agent has to write a test that is designed to fail. That's RSD. Then it has to watch it fail.
It has to actually confirm the failure.
It has to. Then, and only then, does it write the absolute bare minimum code to make that test pass. That's green. Once it passes, it refactors if needed and commits.
Okay, that's standard TDD, but the enforcement is what's new here.
Exactly.
And here's a detail from the sources that just shows the sheer rigor of this system. The test-driven development skill will actively delete code that's written before its corresponding test. It doesn't just flag it, it removes it.
Yes. And that deletion mechanism is so vital. It directly addresses the core weakness of these large generative models. Which is what? They're trained for high-speed output. Their default is to just generate big blocks of code. This dilution thing, it physically removes the possibility of the agent relying on that instinct before following procedure.
So if it tries to write a function and then write a test for it after the fact,
the function gets wiped. It forces procedural adherence over just, spitting out code. It basically programs out the temptation to cut corners.
that's a huge philosophical shift. It means the AI achieves autonomy by being more disciplined than the average human developer. And once the human says go, the execution phase starts, which the sources call Subagent-Driven Development, or SEDD.
Yes, SADD. It uses the executing plan skill. This is where you get maximum throughput. Once the plan is validated by the human, the system dispatches a fresh subagent for every single one of those 2 to 5 minute tasks.
A fresh subagent for every tiny task. Why not just use one persistent agent to do the whole thing?
Context drift. It's the enemy of reliability. A single LLM trying to hold the context for an hour-long project, its memory starts to degrade, it misinterprets old instructions.
I see.
By launching a fresh subagent for each microtask, you guarantee a perfectly clean, focused context. It's only thinking about those 2 to 5 minutes of work. It's like a Formula One pit crew, where each person just tightens one specific lug nut perfectly, and then they're gone.
That's a great analogy. A highly optimized temporary task force. And the sources say they can work autonomously for hours without deviating. Which brings up the big question of quality control. How do you stop the human developer from just drowning in automated pull requests?
The quality control is baked right into the transition between tasks. It's a structured 2-stage review process. First, tasks are automatically reviewed for spec compliance. Did it do what the task said?
Yep.
And then second, for code quality style, DRY principles, things like that.
And that's all managed by the requesting code review skill. Does it just flag things, or does it actually enforce consequences?
Oh, it enforces consequences. It activates between tasks and reports issues by severity. But critical issues, like test failure or a clear violation of the plan, don't just get a comment. They block progress.
So it actually stops everything.
It stops that subagent, yes. The human is only brought in when there's a critical flaw that needs real project oversight.
And even before the agent starts coding, it uses a key skill, using Git work trees. For anyone listening who isn't a Git specialist, why is work tree so important here? Why not just a new branch?
That's a great question. A standard Git branch shares the same working directory, but a work tree gives the agent a completely isolated, standalone environment. It's a parallel copy that doesn't interfere with anything. So the agent uses that skill to create the isolated space, run a clean test baseline, and make sure it's starting from a verifiable clean slate. It guarantees isolation.
That level of rigor, it really speaks to the maturity of the framework. It's not just generating code. It's building a professional environment around the generation. And that includes debugging.
Right. Debugging is where real engineering discipline shows up. The systematic debugging skill mandates a 4-phase root cause process. This isn't just try a fix and see if it works. It uses techniques like root cause tracing to force the agent to find the origin of the bug, not just the symptom.
So it can't just slap a temporary try-catch block on an error and call it a day.
Absolutely not. And once the root cause is fixed, the agent has to activate the verification before completion skill. This makes sure the fix is confirmed by the original failing test and also by any regression tests. It prevents fixing one bug only to introduce 3 more.
Okay, so we've covered design, planning, strict TDD enforcement, execution, QC, debugging. It's a whole workflow. How does a user actually get these superpowers? Is it some expensive proprietary tool?
No, and that's one of its biggest strengths. It's an actively maintained open source project. Over 17,000 stars on GitHub, 1,400 forks, all under a permissive MIT license. It's really a community-driven mandate for code quality.
And the installation must be different depending on the underlying AI model you're using.
It is. If you're using something integrated like Claude Code, you add it through a built-in plugin system. A simple command, like plugin marketplace, add Ober Superpowers marketplace. For models like Codex or Open Code, which often run in local environments, you'd fetch the installation instructions from GitHub and follow a manual setup.
And how do you know it's working? How do I confirm that Superpowers is active and ready to enforce all this rigor?
You look for the core operational commands. Once it's installed and running, you'll see commands like superpowers.brainstorm, superpowers.write-plan, and superpowers.execute-plan pop up in your interface. That's your confirmation.
Right. So after all the subagents have finished their 2 to 5 minute tasks, how does the developer wrap it all up? What's the cleanup stage look like?
That's the finishing a development branch skill. The agent does one final verification of all the tests, a full sanity check, and then it presents the human with a set of options.
Yeah.
It'll offer to merge the branch, create a pull request for a team review, keep the branch open, or just discard everything. And then crucially, it cleans up that isolated work tree it made at the start, returning the environment to its baseline state.
So what does this all mean? The sources show the goal here isn't just speed. It's about consistency, eliminating corner cutting, and enforcing proven methods like TDD through code. The fact they even have a guide for contributors. The writing skills still shows they're really serious about building a community around this philosophy.
Absolutely. This deep dive really showed that the cutting edge of AI coding is, maybe surprisingly, less about creative genius and more about a relentless, systematic adherence to process. The AI scales engineering rigor by forcing a disciplined workflow that minimizes reliance on human judgment, which can be flawed or tired or just hurried.
So the system achieves its reliability and its autonomy by being inherently more disciplined than many of us. It has literally programmed out the temptation to just push the code and say, I'll write the tests later.
Which leaves us with a really provocative thought for you to consider. If these autonomous AI agents, using subagents and process enforcement, can manage hours of disciplined, TDD-driven development, what core functions of critical thinking and project oversight will actually remain exclusively human? I mean, what does a human QA or code review role even look like when the AI is automatically deleting its own bad code the second it deviates from the plan? That's something to mull over the next time you decide to ship without a refactor.
Thanks for joining us for the deep dive. We'll be back soon with more insights distilled from your sources.